We're at Citizen Machinery. PET control, PCC, programmable chip control, if I'm correct, has been around 20, 30 years, but you've got the latest technology, which is LFV. Now, what does LFV stand for, first of all?
Low frequency vibration.
What is it?
It's an oscillation between the spindle and the axis cutting.
Okay, so why would I use it?
To control your swarf.
Okay, so when you say control swarf, at the moment I'm running sliding head machine, nice big 3 metre bar feed, 24/7. It occasionally stops because it's built up a bird's nest.
We won't have that.
Oh, simple as that. There's no, so...
Yeah, it will, we can chip the material, we can tell it how long the chip needs to be to control it, and we can run lights out. That's the main thing. You know, no operator involved. Well, to set up, of course.
So, in terms of, so at the moment I'm making a component, do I have to reprogram it all? Is it quite straightforward?
No, we just add the G-code. Maybe bring the feed rates down a little bit, but that's it.
So question marks in terms of, you've got your, at the moment you've got your bird's nest, so you can now run it 24/7 because you're chipping. What sort of materials?
Any, you know, up from copper all the way up to hard hastelloids, Inconels, duplexes, anything you want, really.
Plastics?
Plastics. That's one of the best.
So Chris, best thing really is to show me an example, please.
Yep. And here's some run-of-your-mill aluminium what we've got, and this is your before. Yep. Standard stringy bird's nest, 3-4 mil depth of cut.
Yeah, nice big cut there though.
Yeah, that's it. You have to run it a little bit slower, you know. And this is...
This is one you prepared earlier?
This is one what I prepared earlier. This is with the LFV. Still your same depth of cut and fully chipped.
You mentioned aluminium as an example, but you can buy aluminium that chips anyway?
Yeah, Sigma chip.
Okay. But so what's the benefit then of the LFV if you can already get the chip in aluminium?
Premium of your aluminium.
Okay, so you standard, this will run standard aluminium, chip it?
As long as it's H9 tolerance, that's all you need.
Okay, so pretty much any material, you can use the standard material as well, not the like the Sigma as you mentioned?
Yeah. You know, you don't need your fancy free cutting stainlesses or anything like that. It can just be your normal stainless.
Okay, what about, I mean, engineers are going to see this as new technology. What about things like tool life? Because it's surely with that oscillation, it's going to damage your tools potentially?
It doesn't. It actually brings the tool off the job, which will allow lubrication per rev to get between the tool and the job every rev.
So essentially extending tool life potentially?
Yeah, potentially. I'd say it's no worse.
Okay. So ultimately you've got the benefit of being able to run the 24/7. What about cycle time then? Because surely if you're going to be running it slower?
No, same spindle speeds if you want. If you want to rein it back, we can pull it back because we can still chip the material. We don't have to do it the old-fashioned way of running the swarf off the spindle. We can just chip it at a big depth of cut. So you might not need a rough pass in there. You can just hit it in one go.
Chris, you've given me, well, a nice insight into LFV. I want to see what you've actually done and made a component, please.
Here you go.
So what's the sort of before and after process on this component?
So the before process was turning up to these shoulders, rough turning, and then finish turning afterwards.
Okay, so essentially two cycles.
Yeah, exactly. Yeah. The only reason we've done that, they were doing that, is because with the rough turning, we had a bad finish, and the material started to black as well.
Okay. So that's 1 op, 2 ops, 3 ops.
Yeah. So you got sort of 4 operations to get up to this shoulder, and then they were turning the rest of it in one hit.
So, yeah, essentially you can have that tool change, whatever it is. So 4 ops, now you're doing it all in one op with the LFV.
One single pass.
So, as I said, and I don't want to go too much, but 4 ops now down to 1. So, in terms of engineers' question, cycle time, it's coming down.
Yes, it's coming down because, well, especially on this component, because we could single pass it.
So 24/7, bring the cycle time potentially down. Surface finish, so you said, it's because engineers will question with this type of process, it's going to make a different surface finish?
It will, and most of the time it's made it better. It's like a semi-burnish just over the top of as the tool pulls back, it burnishes the top of it.
Okay, so again, reduce those cycle times if you need that certain surface finish.
Yeah. So you hit it in one go, finish it in one go.
Makes it sound simple. Right, so you've sold me on LFV, how it's making the whole production process better. How do I get hold of that technology?
You come see us at Citizen.
Okay. But well, you say that, but does it come with a machine? Can you retrofit it?
It can't be retrofitted. It's not economical to retrofit it. Our machines are designed from the ground up to be LFV ready.
Okay, so it's not just a case of adding software.
No, ball screws, lubrication system, guards. There's a lot of stuff involved.
Okay, so it's not. So the machine is really built to take on that technology.
It's designed to take on the vibration, yes.
So in terms of the actual machine itself, you say rigidity. Is it on a ball screws, linear drive?
Ball screw.
Okay, so you still got, but you've got the linear.
Linear rails, yeah. Your linear rails.
So again, that ties in nicely with Citizen Miano in terms of speed of machine accuracy.
Exactly, yeah. Our machines are still fast.
Okay, Chris, you told us about technology. Great component there. So if I wanted to get hold of it, what do I do?
Come and see us and we'll get a test cut done.
Oh, so you'll actually showcase what you can do.
Exactly. Bring some material down and we'll cut it.
Nice and simple. Thank you very much.